to the third demo video for Securade. In this segment, we will actually take a look at how we can combine the various features and the capabilities of the Securade Hub Edge AI platform to ultimately design a bespoke solution for a customer problem and deploy it at a customer site. So if you haven't looked at the first two videos, I'll request you to go back and see them. So the first video was where we actually showed the workplace safety solution, and in the second video, we showed the Securade Hub Edge AI platform, right? So now, in this particular video, we want to show you how we can combine these things to solve a customer's problem. And as it is often, it's actually a bit challenging to describe and create a scene, which would capture the essence of how we go about deploying this technology in a new customer site, right? So what I've done here is, in order to help me do that, I'm going to use again the Lego figureheads. And what you see here is, say, a scene at a particular customer site, right? And we have three workers who are working together. We have some excavators, we have some signs, and so on and so forth, right? So one thing you would notice is that when you take something to a customer site like this, there might be some objects which you cannot detect because you haven't trained on them, right? So here, this toy excavator is something that the model cannot detect, right? So the first thing we'll show is actually how we can use uh, techniques from generative AI to actually uh, create and train a object detector for a novel object like this excavator in a very short time, right? So we take as little as 5 images, and in 5 minutes we are able to do it. So I'm going to take this excavator and I'm going to just take a few um, images from my uh, phone camera as you can see here. So I'm just going to take a few images here, right? And I'm taking images from different perspectives, but you can, right? And then one maybe from the top, right? So I just took 5 images, right? And I'm going to transfer them to my computer. So let me just do that. Right, so just gonna airdrop them into my Mac so you can see that it's gonna come here, right, on my screen. And what I'll do is I'll just figure out where they are, right? So one thing here is that they are actually all in HIEC format. So I'm gonna just convert them to PNG, which is something we can then work with. Okay, so here they are. I'll just select all and export. Okay. Just want to make sure there are no other images in here, right? And I'm gonna save them here. Okay, and now I'm just going to run them through my processing pipeline here, which uses generative AI, right? So typically, to train a new classifier for a object like this, which you haven't seen before, one has to use a large number of images. So if you remember our previous video on the Securade Hub, where we showed that we support any open source model, or you bring in your own model, or you can directly use the RoboFlow 11, RoboFlow 100 object detection benchmark. You notice here is that like the number of images that they have, the number of classes they have. So in order to support a new category or support a new object for detection, you usually have to label a large number of images, you have to annotate them, you have to draw bounding boxes. We shortcut all of that here by using techniques from generative AI. So I just took 5 images and I just copied them over, and I'm going to just run them through my pipeline, and then out we will see an object detector which can detect this new and novel object, right? So here I'm actually uh, running it through a generative AI model, which is going to automatically label and draw the bounding boxes around the images, right? Um, yeah. Once that is done, I still have to fine tune it, so I'll make sure my collab here is ready so that I can start the training. And meanwhile, as the new object detector model is getting fine-tuned, we'll go ahead with the scene which we had created in order to show you some of the considerations on how we can deploy this technology at a customer site, right? So it's done 3 images. Let's just give it a few more seconds. Okay, one more image. So one thing I noticed here is that the images are really big in terms of the size. So I'm going to just adjust their size um, so that the processing is not that slow. Okay, I just did that. All right, and then I think this one was left. Yeah, so let me just resize this image as well. Okay, here we go. All right, so I have some images. I'm just going to run it through my pipeline. So this. Okay, we have some images here. I'm gonna do the split and then just zip the folder. Right now I'm gonna upload this here in my collab. Okay, so it's gonna take a few seconds to upload. So doing it on Colab because my MacBook here doesn't have a GPU, so I can't fine-tune this model. So that's why it's taking a few minutes. But otherwise, on the edge device, which we have, all the steps of this process actually can happen seamlessly all at once. So you don't have to copy and move things around. The only thing you have to do is to just take the pictures from the of the object that you want to detect. Okay, so let me try and go back to the scene that we were looking at, right? So typically when you're trying to, deploy this technology at a customer site, there are some considerations to look at. So the first thing to think about is like, what is it that exactly that you're trying to, you know, detect in terms of safety violation, right? So what is the activity that is happening? What are the conditions under which we would say that the risk has occurred, right? And then try to implement that using the capabilities of the platform, right? So here, what we've done is we have a camera which is pointing towards the work site here where the few workers are, you can see, are working. And usually, camera ideally is mounted at a slightly higher point with so that it gives a isometric view of the space, and you can draw the polygons in a much better way, right? So you can see here that there is an exclusion zone which is marked within the image, right? So maybe in this zone there is some critical activity. You can see that there is a stop sign, so maybe humans should not venture to this into this zone, right? Um, Now let me just go back and start my training, and I will come back to the scene. So I think this is almost done. Yeah. And now we're going to just start the training process. I just want to make sure that the training is okay. Now this, and looks like the model has started training. And we go to the output. No, go to the runs, train, and this is where the weights will be. Okay, so here it looks like the model has started training, and we'll come back to it once it is finished, right? So now let's go back to our worksite where so far we have installed the camera and we've figured out that, okay, this is the area or an exclusion zone where we want workers to not enter unless they're wearing a PPE, for example, right? Now, in order to make things more interesting, what I will do here is I'll just switch off my light, okay, and create some more realistic um, lightning conditions for us to work with so that you can see that we can detect things even in an environment where there is not complete bright light, right? So now here's the scene. As you see, we have three workers, and two of them are here, not wearing any PPE, and one of them is wearing a hard hat, right? Now, if they are outside the exclusion zone, as you see, so maybe we move this guy here, we put this here. So when they're outside the exclusion zone, you can see that they're marked in green, which means that it's okay. But as soon as she enters the exclusion zone, you'll see that she's flagged for a safety violation because she is not wearing any PPE, right? So see, just let me just move her all the way over here. And so this worker is in violation because she's not wearing any PPE kit, right? So On the other hand, if we, let me just leave her here, right? So mark red. Now, on the other hand, if we have this worker who is actually wearing a hard hat, and if he enters the exclusion zone, you'll see that it's okay. He's not marked in red, right? Because he's wearing a hard hat, right? So so this actually shows the ability to actually combine two policies at once, right? So we have the PPE policy, and we also have the go no go zone policy. So what if you're wearing a PPE kit, if you're wearing a hard hat and you're in the exclusion zone, it's okay. But if you're not wearing a hard hat, then you come into an exclusion zone, then uh, you're marked in red, right? Now let me see if I can adjust the lighting a bit more. Yeah, right. So marked in red. And if you're outside, it doesn't matter if you're wearing a PPE kit or not. As long as you're outside the exclusion zone, um, it is okay. Right. So, okay. So let me move this guy here. And as long as you're outside the exclusion zone, even if you're not wearing PPE kit, it's okay. But to be in the exclusion zone, you have to wear a PPE kit. Otherwise, you'll be marked in red. Right. And let me just try and decrease the light even further to show you the effect of low lighting on detection. So here you see, even with this low lighting, if I'm outside uh, the zone, I'm okay. I'm green, right? Um, and so this is already wearing hard hat. So this one, so if I, even in this lighting, if we are outside the exclusion zone, the object is green, and as soon as it enters the exclusion zone, you'll see that you can mark it as red, right? And all of these violations, they are actually um, getting recorded. So if we go back based on the policy we have, right? So if we go back to because by default, it always records the violations as a DVR. So if I go here, um, this is camera 0. Okay, it's at 10 seconds. So let me just put it in here for like 10 seconds, and hopefully it will capture the violation here. Yep. So because the duration was marked as 10 seconds, so you have to be continuously, so you can see that it's able to capture the violation, right? Okay, so hopefully this gives you an idea of how one can deploy this technology in at a customer side, and what are some of the considerations that you need to take into account, right? Um, so let me just go back quickly and see that the model has been trained. So let's just download this file, right? And what we will do is we'll just copy this file into our model zoo, and and we'll change our model here to be that, and not exclusion. We're going to put the custom policy. So here we go. We downloaded this model. I'm just going to copy it and paste it here in the model zoo. Let's just call it test.pt. Okay, and I'm going to just choose this model here, and let's see if we are able to detect that excavator that we had, right? So let's load the system, and now you can see that it is actually able to detect the object which you just trained it on, right? So this was the excavator which we just trained it on, and now uh, earlier the model was not able to detect it. Now it can detect the excavator, right? Let me just take my hand away. Okay. So now in order to convince you that it's not just, overfitting on this one particular toy, I have another one which is very similar, but it's not the same. And you can see that it does actually detect this as an excavator, right? So it's not just overfitting on this one particular toy. Okay, so if we try and place them together, you can see that it does detect actually both of them as excavators, right? And we are able to do that just with as few as 5 images within 5 minutes, right? So this really allows us the capability to deploy at a customer site, and on the site, uh, train a new or fine tune a new model based on the objects that we may not be familiar with and immediately apply it. So this makes the Securade Hub based solution 100 times better than anything else in the market, because we have the capability to detect and train a model for a object detector on the fly, right? So with all that, let me wrap up at the end by showing you some of our real deployments that we have currently running. So let me show you our first POC, which we set up at Omron uh, in Singapore. So this is the Omron's facility in Singapore. And the use case there is very interesting. It's actually to protect humans from getting too close to their robot. So I'm going to just start the video. I'm going to talk through what it does, right? So we have a camera which is mounted high up. So like I said, an ideal location similar to a CCTV camera, high up, pointing downwards, giving you a 45-degree isometric view of the scene. And here you see the actual robot which we are trying to defend. So this is Omron single armed robot which can automatically unload boxes from a container or a truck. It's attached to a trolley, so it unloads the box, places it on the trolley, and then it just moves and so on. So the robot is smart, but humans, when they venture close to it, they can get too close to it, and there might be a potential safety issue. So what we did is, how we actually implemented this particular situation is that we draw an exclusion zone around the robot, and if somebody ventures too close to it, as you see here, the two people, it flags them as a safety violation, right? And if you're outside the exclusion zone, it is okay. So, and we were able to do all of that on the fly, right at the customer site. So you don't have to spend time and effort to, figure out the requirements, come back in, build some custom piece of software. You can do it all on the fly, right? Now I'm going to show you our second POC, which we have with the Axis. So this is actually demonstrating um, the alerting capabilities. So what I have here are two additional devices. So let me just play the video first. Um, I have the Axis camera. So this is the Axis camera. And then we have something interesting here, which is Axis network strobe or a network siren light, right? And the situation here is very similar to what I just shown. So you see there is a blue colored exclusion zone. And if I stand outside the exclusion zone, I'm green. When I get too close to the exclusion zone or the zone where it's marked prohibited, and when I get close to it, you can see that it says that you're not wearing a quit. And the siren actually beeps. So we are actually able to alert in real time about a safety violation. So if you enter a zone without a PPE, the siren starts beeping. And if I wear the PPE kit, so here I'm putting on the vest and the hard hat, and when I come back into the exclusion zone after I'm wearing a proper PPE kit, you'll notice that there'll be no violation. So here the warning is gone. It's blue because I'm wearing the PPE kit. Now, at any point while I'm walking within the zone, if I remove the hard hat, you'll notice that the siren light will beep again. And here it detects as a safety violation. Yeah, right. And then once you put it back on, the light stops. Okay. So this just shows that how we can also do real-time alerting within the same environment based on the safety violations that we detect, right? So that's it. So hopefully we're able to convince you that no matter what your use case, we can actually very rapidly configure and build a solution that meets your needs because of the capabilities we have on the Edge platform, as well as our ability to generate any object detection model on the fly using generative AI. Thank you.